Hey everyone! Before we move on to the next part of solving linear equations, we need to establish something real quick so that way future problems will be a little bit clearer. It also expands our options, and we can never go wrong with expanding our options. One thing to recall to start things off is a quick little reminder that parentheses, whenever we're referring to an equation or expression, usually means multiplication. That is, if you were to ever see something like the following, I'll put a little example right here. If you saw something like 3 into 6 with a 3 outside of the 6, this usually means 3 times 6 in mathematics. Same thing would go if we had variables in the mix. Something like, say, 3 into x, and that would be basically 3 times x. But what happens when we have a whole expression in parentheses? So similarly, how do we handle something like, say, 2, open up your parentheses, x plus 1? What does this equal? Well, we know that the 2 is outside, so this is kind of like its multiplication, right? But how? Well, that brings us to something called the distributive property. So enter the distributive property. And the way it works is as follows. All right, so we multiply the outside number by each inside term. So for example, let's take that 2 into x plus 1 example that we mentioned before. The way this works is that the 2 as our outside number, whoops, sorry, bled on the screen a sec. This 2 right here is the outside number, while x and 1 are the inside terms. What we're going to do is we're going to multiply 2 by each of those terms. So start off with 2 times x, then add, the sign will stay the same, 2 times 1. Then we just do those multiplication problems, those individual ones, 2 times x. We can just write 2x plus 2 times 1 is just 2. So there we have it. A quick thing to note as well, we don't really need to talk about this too much now, but we will talk about it way later down the road in algebra, is that this side right here with the parentheses is called a factored form, while the version after we do the distributive property is called the expanded form. Again, we'll worry about this much later down the line when we do quadratics, but it's good to know from now. Let's do a couple of other examples, so that way we can get in the swing of things. The outside term doesn't necessarily have to be a number, or even just a positive number. We'll see that right now. I could have x on the outside. In the example, x into x minus 10. Same thing as before. It's often a good practice to draw these little arcs, that way you know exactly what you're multiplying. So here, we start off with doing x times x. X times x gives you just x squared, while x times 10 is 10x. Now, unlike before we had a plus sign, this time we have a minus sign in between. So in between the x squared and 10x, we're going to replicate the sign as minus. So make sure you replicate the sign. I will make a note of that right here. Don't forget the same sign, or else the algebra fairy will get you. Oops. It also has little horns too. Right. Let's do a couple more, just to demonstrate a couple of other examples. For instance, what if we had a number that was negative on the outside? Like negative 5 into 3 minus x. Alright? So the negative 5 on the outside has a one-way ticket inside, So the entire thing is going to break and enter and visit the 3 and visit the x. So what will happen to it? Well, negative 5 times 3 is going to be one thing we're going to do. We're going to preserve the sign of the minus out here. Minus negative 5 times x. Now, we multiply everything together. Negative 5 times 3 is negative 15. Minus negative 5 times x is negative 5x. Now we can take these two minus signs over here and make them plus. So our final answer will be negative 15 plus 5x. And look, we're safe from the algebra fairy now. One more example. It's not one we're going to see very frequently right now. Might be something we see later, but it is good to know just as a general word of caution for the distributive property. We've noticed that in all 3 examples so far, we've used 2 terms on the inside of the parentheses, but this can work for more than that. It could work for 3, 4, even 5 terms, as many as we need. The most important thing, though, is that our outside number will break and enter for every term on the inside individually. So here, we'll do 10 times x, then 10 times y, then 10 times 5. So here will be 10x plus 10y plus 50. All the pluses reserved. All right, awesome. As a little practice for you, if you want to do a little bit more practice on your own, give these 2 a try. Let's do 6 into 6 minus x and negative into x minus 20. All right, make sure you get some practice, and we will talk about this tomorrow.